Chapter 3 Study Guide, Question 25, my personal favorite. This is in Auburn, Alabama. And so if you're an Auburn fan, just know that these streets will be familiar to you one day if you choose to go to Auburn. College Street. So y'all, what is happening here is that they're giving you a verbal description and of these streets, and then they are asking you to find the relationship between two of the streets. So let's just go one by one and let's label it as we go. College Street intersects both Glen and Thatch. And so let's just start with college, okay? For some reason, I always like to draw my first line flat. I don't know why. I just like to draw horizontal lines. So here's College Street. Do I have an orange? Well, that's unfortunate. Hold on. We can add one. Sorry, Alabama fans. It intersects both Glen and Thatch. Now, originally, it doesn't say how it intersects them. So let's just keep reading. Thatch is perpendicular to college. So I have a friend that named their child Thatch, and so it's perpendicular to college. So what that means is that it crosses it, and it crosses it at a right angle, or a T. And so that is going to be Thatch, T-H-A-C-H. It's perpendicular to college, and it's parallel. Thatch is perpendicular to college, but also parallel to Glen. Okay, what that means is that Glen is also crossing college, because it said that they crossed, but it's parallel to Glen. So here's Glen. It is perpendicular to Thatch, but it does intersect college. It wants to know what is the relationship between College Street, this one in blue, right here, and Glen Avenue, this one right here. So we learned a theorem that says if you have a line that is perpendicular to one of two parallel lines, that means it also must be perpendicular to the other. So what is the relationship between these two? Those are going to be perpendicular. So we know that college is going to be perpendicular. That means perpendicular to Glen. Okay, so that is my final answer. Those are going to be perpendicular to each other. Why? Because we know if those lines are parallel, then corresponding angles must be congruent. So there is a right angle living here, even though it's not drawn, because those lines are parallel. All right, next section says, find the values of angle 1 and angle 2. Justify your answer by stating the theorem that you used. All right, so why, if these lines are parallel? We could not do this problem if I didn't know that these lines were parallel. So if Q is parallel to R, let's write that first. If Q is parallel to R, how do we know what angle 2 is? Well, what is angle 2? Angle 2 is going to be corresponding to 130 degrees. So we know that angle 2 is going to be equal to 130, because those are the same corners. That is because of the corresponding angles theorem. If the lines are parallel, then we know that the corresponding angles must be congruent. And what is angle 1 going to be? Well, together those make a linear pair. So what is 180 for this whole thing, for this linear pair, minus 130, that is going to give me 50 degrees. So what is angle 1? The measure of angle 1, I should have put measure on this other one. Measure of angle 2 is 130 degrees. Measure of angle 1 is going to be 50 degrees because that is a linear pair with 130. Okay. All right, let's look at this next one. Again, I noticed that these lines are marked as parallel, so we need to start with that. Could not do this problem if D was not parallel to E. So D is in fact parallel to E. We know that to be true. Since D is parallel to E, if this is 79, what is angle 1 going to be? And the measure of angle 1 is also going to be equal to 79 degrees. How do I know that? Because those are alternate exterior angles. And the alternate exterior angles theorem says that if those lines are parallel, then those alternate exterior angles must be congruent. So this is also going to be 79. Well, then what is angle 2 going to be? Angle 2 is going to make a linear pair with 79. So we're going to do 180 degrees for that whole thing. So let's do that real fast. That whole thing would be 180. And so what is 180 minus 79? That is going to give me 101 degrees. So the measure of angle 2 is going to be 101 because it is going to be a linear pair to angle 1. Okay, so once we know angle 1, now we know angle 2. All right, let's go to this next picture, number 28. Number 28 is interesting because we have one set of parallel lines, and then we called this, I want to say we called it the wonky hashtag, because what we said is that this transversal, it has to be different than this transversal, simply because those are not parallel. And so if this angle is 76 right here, what is angle 1 going to be? The measure of angle 1 is going to be equal to 76 degrees. Why? Because it is interior to the 76 degree angle. All right, well, if this angle is 119, it is going to be supplementary to angle 2. So what is the measure of angle 2? It's going to be 180, which is the sum of those two, minus 119. What does that give me? That is going to give me 61 degrees. So 119 plus 61 is going to give me 180 because that is going to be the same side interior angles theorem, which says that those must be supplementary. So 180 minus 119 gives me 61 degrees. And that makes sense because that is an acute angle. Okay? All right, let's look at this last one, number 29. So again, I have my parallel lines, A and B. They're marked as parallel. And then I have my kind of wonky hashtag symbol because the pink one and the yellow one are not parallel, which means that they're going to be different numbers around them. So we know that if this is 58 degrees, if that is 58 degrees, well, then what do we know? There's several directions we can go here to find angle 2. What do we know? We know that vertical angles, this is going to be 58 degrees. Well, then what do I know about angle 2? Angle 2 is going to be supplementary to 58 degrees. So that's obtuse, this one's acute. And so those should add up to 180. So these should have a sum of 180 degrees. So what is 180 minus 58? That is going to give me 122 degrees. Why? The way I've done it is because it's same side exterior to the 58 degree angle I created with vertical angles. After vertical angles. Multiple ways to do that problem, but we could fill in all of those pieces that are going to be acute are going to be 58. All of the other pieces are going to be 122. All right, let's do that same thing on this other problem. This is an 82 degree angle. What is angle 1? Angle 1 is going to be corresponding to it. So angle 1, the measure of it, I should say, measure of it here. Measure of angle 1 is going to be equal to 82 as well, 82 degrees. Why? Because it is corresponding. The corresponding angles theorem says, hey, if that is corresponding to this top left corner and this top left corner, those are going to be congruent. And so if the other one is 82, the measure of this one has to be 82 as well. So this would be 82 degrees. So angle 2 was 122 degrees.